firstly welcome you all to this Institution of Engineering and Technology Sussex Network talk. Our talk is tonight by Professor Mike Underhill. And most of you know Mike because he's the chair of our events subcommittee. That's the group that puts together these talks. You perhaps more usually associate him with radar and microwave communications, but he's hopefully this evening will tell us about some other interests that he has. In fact, we read a lot about climate change, and quite often the example is given is the shrinking ice sheets in Antarctica. But I only know one person who's been to Antarctica, and that happens to be Mike. So I'm hoping that we'll find about a little more about the region and the science and the impact on climate change.
Science and Technology of Antarctica. So this is all about a journey and results of it, which with Hertie Gruton, which actually was from the, let's see if I can work this, yes it does, which went from the Falkland Islands, from South America to the Falkland Islands to South Georgia, and then to the Antarctic Peninsula here. The journey was in this rather fine ship, the MS Fram, and there's a little bit of details, if I can, here, which I'll show you in a minute. But the journey of note actually went across the ocean currents around Antarctica. So, sorry, we'll have to go back. And on the right-hand side here, let's get the thing. On the right-hand side is a map which is rotated round, so that Argentina is here, and we are in the interest place. Sorry, I've got to kill my touch screen at the moment. Yes, that's better. And then go back, go forward, and then just to show that part of the journey is necessarily across the Drake Passage, which is part of Antarctica. Well, here is the Antarctic South Pole, and you can see again. And on the right, you can see a map which shows the land under the ice. So the first thing to learn about the Antarctica, that the land under the ice is actually, sorry, the land under the ice, I'm not going to be able to use the pointer easily, so let me just stop the touch screen. The land under the ice is let's see if this works. No, it doesn't, so I'll put the touch screen on, see if it works. Yes, it does. So the land under the ice here is actually a 1/3 of the total area of what we think of as Antarctica. So it's about 1/3. Moving on, the land is measured under the ice by ice penetrating radars, which operate 2 to 200 megahertz, and satellite radars at either 9 or 60 megahertz. And here's a picture of some of the early measurements which have been made by radar. And you can see an aircraft, I think it was a B-52 or something, and it has a long antenna, 120 meters, which went out to a Teflon drogue or at the end. More recent stuff, you can see the antennas on the aircraft here. And again, more recently as well, you can actually do measurements dragging a sledge across the ice, or you can, on the right-hand side, you can see that there is a drone, and also there's another ice-borne one here up here. So these ones all measure the ice. Now I'm going to try and run a video, and here it is showing Antarctica, and it is what is measured by radar. And you can see that it's very fascinating structure underneath the ice, which has been found from radar. There's something like million miles of several million miles of measurements, all been compacted together by computer software. Some of the measurements are done 10 years ago, and they've all been assembled together to give this rather impressive 3D response, showing what it's like underneath Antarctica. Sorry, next one. Here are some facts about Antarctica, and you'll see on the right-hand side the picture of all the research stations which there are currently running. And it tells you something about the area of Antarctica. It's about equivalent to 2 Australias. It's very large. It's bigger than the United States in area, and it's equivalent to Australia twice. Population density rather small, 1,000 to 1,000 seasonal. I think it's possibly a bit less now in the winter, but that is what it is, and there's some other details there. Here's the research stations on a more user-friendly map, and the ones that are of interest to us are Rothera here, which is British, Halley, which is British, and another one which is up in the Orcadius. Those are the main British ones. There is a research station which is the Amundsen Scott one at the South Pole, and also the biggest one is the American base McMurdo Scott one down at the bottom. So there are several facts which I'll go through quickly about Antarctica. It's the 5th largest continent of our planet, and it's double the size of Australia, as I've just said. It's actually, well, I've already said that one, so I'll move on, but there's some facts and figures there which you can read. It's the least populated continent. It's the driest continent. It's been in force. The Antarctic Treaty governs it. It's brought in 1951. It's now signed by 53 countries, and it doesn't give the date there, but I think it's in 2048 it runs out, so it's got to be renegotiated that. And so there are 18 countries that regularly use the continent, and it is the highest continent, and this is a surprise. Antarctica has the highest average elevation of all continents. Most of it's higher than 3,000 meters. That's awfully high, and the Mount Vinson sticks out through it. There's little or no ice required for there to be any flora, but it's basically tundra vegetation, tundra plants, small scrubs, grasses, and mosses. The wildlife, well, you'd expect it, lots of penguins, and the emperor penguins, which we did not see on our trip, was the largest, and some of the penguins are actually in decline. Some of them are actually building up. The climate, it's the coldest place in the Earth. It's much colder than the Arctic, and there's some temperatures which you might like to make a note of. So the geographic South Pole is, you've seen it on the previous map where it is, and here's a picture of it, and it's the the Amundsen Scott South Pole Station, which is located next to it. Various explorers have been there, and Roald Amundsen, Ernest Shackleton, that was the one, the British one, very interesting. I'll have to not pass it, do some of the parts of that. Now, there's a huge ozone hole, or there was, and this is one of the good news bits of from Antarctica. It's actually getting less. It's one of the things which is improving as a result of action taken against aerosols, or the CFC type aerosols. There's a huge number of tourists, of which my wife and I were one originally, and the islands, and I'd hoped to get some pictures for Deception Island, but run out of time. It really is fascinating. It's a former whaling station. It's an active volcano, but it is actually an island which is hollow, if you like. It's got a little mini lake or sea, quite a big lake inside it. And originally, when the ships sailed around it, they couldn't find a way in, but there's quite a narrow outlet. But unfortunately, I haven't got pictures of that on this show. Right, another picture of the land under ice, which I'll run through, which we can see here on the video. And this is of particular note because it shows the many glaciers and emphasizes just how much the Antarctic is, in fact, covered with very thick ice indeed, an awful lot of it. So look out for the signs of the thick ice. And it is also showing, well, it's showing the Thwaites Glacier here, and there's water under it, and it moves on across. It's going roughly in a clockwise direction around the Antarctica. And when the name comes up, I'll remember which glacier we're seeing now. It is the Bird Glacier. Notice the great chasm which there is on that. Some of these, the depth, there are great chasms under which you can't see, of course, but they're filled with ice. But some of them actually have water, perhaps because of the pressure under them, but they are fresh water, mainly fresh water, it is thought. But by measuring those, a lot of the history of Antarctica can actually be obtained by measuring the outflows of the water from underneath the ice, of which there are many. The Great Lakes in certain places, which you can get at either by boring through the ice or measuring the outflow water. Ninnis Glacier we're coming through to at the moment. And again, notice sort of great chasms, which are great channels dug out into the Antarctic, which you can see in that way. Right, here we have, I think we're nearing the end. It's the Denman Glacier, and again, great holes in it. It's a very interesting substructure which there is in the Antarctica. So, right, we must be getting near to the end at the moment. West Ragland ice structure. Well, maybe we'll just move on to the next picture at the moment, but it's quite an interesting thing to look at. I'll just leave it to run for a moment, so it can be a complete thing for the video. Right, where are we? We're back again. There's Recovery Glacier, and it must be getting towards the end. Let's just see where we are on the. Yes, we're nearing the end on the screen. This is the end, and you can see it back in roughly the original orientation and position. So moving on, I'm moving on to the history of Antarctica, and here's the two pieces of history. One is modern history. On the left-hand side, although there are 18 countries there are several claims to chunks of the Antarctica. And here is the claims, and you will note if you look at the detail, if you can look at the detail, that the Argentine claim and the claim from the UK do overlap, but there are various other claims for but that's all put into abeyance until 2048. But on the right-hand side is what Antarctica was 130 million years ago, Gondwana land. And then moving to the right, on the right-hand side, is what it is today. So its movement, the Earth crust has moved over 130 million years, quite considerably. Now, this is a comparison between the Arctic Ocean, which is a picture here, and notice that there is nowhere near the, if you look on the left-hand side, Arctic and Antarctically are poles apart, figuratively as well as literally, and we see that it's really an Arctic Ocean, although the ice, as we see on the right-hand side, does cover over substantial amounts of Greenland. You can see that you can relate one to the other. Here is another picture showing Arctic versus Antarctic and the sea ice. March on the left-hand side, February down in summer, in other words, at the bottom in the Antarctic, and winter in the Arctic, and then vice versa, September against September here. So the sea ice itself has extended quite considerably. So it's arguable whether that counts as part of the area, but you can see that the permanent ice is indicated down here at the bottom. The next thing to note, well, first of all, so one of our excellent speakers on the trip was Camille Seaman, and I was going to use some of her pictures, but anyway, watch out for her. She did a rather excellent talk, which actually I've put the link up at the top. So if you want to see her comparing Arctic versus Antarctic, you can operate that link and see. The next thing on the right-hand side is, and I'm going to just have to move my pictures of myself and Julie and David. And here is the sea ice extent at minimum time. I'm just going to move myself and move it again. And here's again, the difference between, this is the extent of the sea ice, how it has varied. And you see the Arctic is, the extent of the sea ice has got distinctly smaller. The area has got distinctly smaller over the recent years from 1980 to 2015. So there is a serious loss of ice in the Arctic, which is not shared by the Antarctic. So it's a very, very different situation in the Antarctic. Now, here's the boat, the ship that we were on, and here are the Zodiacs, which we were on, and some data. So the technology used was very interesting. It had diesel, electric. The more recent boat, which is the Hurtigruten one, is a hybrid motor. So it can run electric as well as a diesel, well, MGO, which is the marine equivalent of diesel. And it's got really clever technology. It's got continuous depth mapping, and it uploads the data to an international database. So it's mapping as it goes along. It's got 3 radars, inertial satellite navigation, satellite TV, internet, internal Wi-Fi, satellite TV in every cabin, and the landings are from, as it shows up at the top, from the Zodiac rib boats. And here is a landing which was undertaken. On the left-hand side, you can see the rib boats. There are 8 passengers and 1 driver. And of particular note is the platform which swings out from the side of the boat, which actually is swung down to the boat level. And here, shown here, is what we have to do. We have to clean our boots when we get off the ship and when we get back on the ship. So here are the brushes which will clean the boat. And this is all because of the biosecurity, particularly in South Georgia and also in Antarctica. And we have these boots. Here's myself in our cabin cleaning my boots, picture taken by my wife, Jill. And here's some boots, but I'm cleaning my boots. That's her boots. And here's she is actually cleaning the boots in the communal thing to give them a really good scrub. Sorry, the thing's playing up on me. And here the boats again of going in and out. One part, were about 200 passengers, 198 I think it is, and you can see that in order to get everybody ashore, there was a regular shuttle of these low Zodiac boats, but it really gave you a sense of adventure. You really had to have waterproof clothes, muck boots, and all the rest of it, life jackets and the rest of it to get on it. Now, the first place which you can call Antarctic is Falkland Islands. It's a very interesting place, and it's got quite a low population. It's about 3,000. It's on here somewhere, and I can't see. Yes, it's that was the density is on the right hand side here, and that was well, that's the density. Yes, it's 3,900 and 3,398, 3,400, call it. A very interesting place. Its income comes from, its GDP comes from its fishing licenses, its tourism and sheep. There has been unsuccessful so far oil search. They still believe there could be oil there. And of course, people who want to look have to pay for a license. It's good income for the 4,000 people, sorry, 3,400 people on the, and also the fishing. Well, there weren't many fishing boats here. The money they get is actually from licenses, which is from the shipping. Now, tourism is really genuine, and that is quite a serious operation here. But first of all, let's look at the Falkland Islands themselves, because they're really divided by the channel, the central channel here, and into West Falkland and East Falkland. The scale is down here. And the West Falkland and East Falklands really are somewhat different places. I think it's about, I don't know, a quarter, no, less than that, probably a fifth of the population, maybe as little as the 10th. I forget the figures at the moment. Is on West Falklands. The main Stanley over here is where the main the main number of people are. There are roads, but to call them roads is a bit of a joke, because except from Stanley, they're really tracks. Certainly in West Falkland, they're certainly tracks. West Falkland's very interesting, lots of things. We landed a couple of times on the West Falklands, and we saw what was particularly interesting was penguins and sheep walking around together. These are the Magellan penguins, and they live in the burrows. There's a burrow shown here, there's another one here of the burrow, and they actually live in these burrows and come out rather strangely different from the normal penguins. Pickford's bottom left. Here's the remains of about 100-year-olds, not sure how old, whale, which got stranded, and then probably the sheep or the actually chewed the meat off it, and it was left there. On the right-hand side, going back again, sorry, there's the shop. There is a shop, but it happens to be off selling out of the back of the Land Rover. So that is in the shop in the West Falklands. And of course, we were tourists. Oh yes, and by the way, whoops, there is the hotel here on the right. There is a hotel mainly used for bird watching, which is fantastic, I must say. There. There is also farming. In the second place we landed, there's farming. Here's a typical farm. I forget the statistics, about 600 sheep. but the sheep are mainly merino type, so wool is the export rather than carcasses. But they're very friendly, and they provide us, when we turn up, very nice business, and subsidized by the Hurtigruten, a very nice meal when we arrive in the right place. I'm going to temporarily just, if I can, right, no, that's better. No, I'm going to remove that down so I can see. Right, here's the Gen 2 penguins, which we saw in another place, and here's getting out and going back from the ship, another picture of that. These are decidedly different. You can see a couple of pictures here and here. They're decidedly a bit different, and they live on the sand, not in burrows, and they make the nests, and here's a great colony nesting at the moment. And on the right-hand side, there's a Gen 2 penguin. They are very, very, well, almost emotional, but they're very caring. Here's sadly a dead penguin, which actually was picked up by a bird later on our particular thing. So there is a dead youngster and their parent grieving, I would say, over it. Here is a typical road, and you can see, well, actually the road was a bit to the left, but basically use a Land Rover. This is another picture of Jill, my wife. But what is particularly interesting is actually looking at the land. It is very poor land indeed, and you can see the layers. It's sort of peat, but not good peat at all. But you can see it's a very layered, and you can see how scrubby it is. So in fact, this density which you can graze it with sheep is not very good at all. Now, one of the things which on the bird side, well, I suppose penguin is also a bird, but on the bird side, that are the albatrosses. And again, they're very strange. There are 22 species, 17 globally threatened total, and they're mainly this one particular variety, about 200,000. And here is a parent, or a couple of parents, this one with youngsters on their eggs, which they actually have in these little nests which are on shelves. And if the youngster actually falls out, the parent has got such bad eyesight that unless it climbs back in again, manages to climb back in again, or at least up onto the rock, the parent can't help it back in again. So it's there was an interesting one on the BBC, Richard Attenborough on the David Attenborough on that one. Here's a picture I took of them in flight. Not a very good picture. Very difficult to take pictures. The light for that one wasn't particularly good, so as it was flying fast, it wasn't particularly good. But they are very affectionate creatures. They basically pair for life, and there's a couple of lovey-dovey scenes there. We also saw some quite near and sharing some of the colony of the Gen 2 penguins, these rockhopper penguins, and hear them, the kind of rock that they climb up. And they have these eyebrows and a little quiff of hair, which is the way they're characterized. So here's now in Falklands, landing in Falklands. Now, Falklands is very, very British. You can see that is the case, because here is, well, I won't say it's a typical, but it was one of the gardens full of garden gnomes. And once again, in this house on the right, then very friendly. They're always ever giving us tea, or in this case, in the morning tea or morning coffee. And also, not far from there, just a little way along the roads, there's Cartmel Cottage, which is a very interesting museum, decked out, shown on the right, decked out on the house is actually dedicated to being a museum, as on the right. Really quite small. Here's a picture inside of the fireplace going up into and through the roof. And here's the kind of bedding that you have. But here's some more things in there. On the left-hand top, there is typical stuff that you'd have in the larder. Here's the kitchen with stuff on the shelves. There's some Marmite. But let's move to the technology. Here's a gramophone and a radio. I think it's with shortwave band, and more of that in a moment. But look on the right. And this is a 1895 45 cottage. And look, there's a radio here in amongst, and that is a real radio. It's a 2-meter amateur radio made by Yaesu, but that has been for many years, was for many years a godsend in the community. And why was it a godsend? Well, there was a little thing called the Falklands War, and when they were invaded, the 2-meter radio was the main link to the islanders, although it used to get jammed, or various other radios used to get jammed. But they were very pleased when the liberation from the Argentinians came, and they actually, on the far side of the harbour, and this is a picture taken, you can see the it's the inlet in which Stanley Harbour is in. You could see on the far side, they put in stones, with white stones, they put the name of the ships there. There's a couple of ships, Endurance on the left-hand side, Protector on the right. And you can see a typical exposition of the Britishness on the right-hand side. Well, radio amateurs have taken a really important part. I did actually visit one, or we both did, and VP8NO, here he is in his Radio Shack, and on the right his rather fine aerial system. But in fact, if you look very closely, there are 2 other radio amateurs within eyesight, so there's a very high density of radio amateurs. But just a little bit of history. Well, I'll save the history till the next thing. But the radio has always been very important. It's only recently that the Falklands Islands have moved from the radio telephone to actually cellular cell phones, and that was well after the Falklands time. Now, a little bit about the Falkland Islands, and this is, well, let me explain, let him explain it himself.
We are here in the West End, opposite Broadcasting House, and let me explain why we're here. Up behind me is a building which is now the Langham Hotel. It's a very expensive hotel, but at the time, this is April 1982, it was a rather ropey BBC office building. But up on the top, where you're looking now, there was an amateur radio station. Now, I am a radio amateur with the call sign G3UML. On the 2nd of April 1982, I'd been on assignment in the Middle East. I came into work and was met with scenes of near panic because the Argentines at 9:30 in the morning, our time, had claimed to have invaded the Falklands, and other than a rather laconic message from Cable and Wireless saying, "We have new friends," there was no indication whatsoever from the islands. We had no confirmation, no news, there were no phones, no internet, nothing in those days. I was asked to go and try and use the amateur radio station, which is up on the building there, to contact the Falklands. Went up there and listened around for most of the afternoon. And mid-afternoon I heard a familiar voice, a fairly distinctive Falkland accent with a sort of West Country burr to it. And I realised this was a guy I'd spoken to a couple of times over the years called Bob McLeod. He was a plumber in Goose Green, about 50 miles outside of Port Stanley. I spoke to him and he said, "Laurie, why is the BBC saying there's been no invasion?" He said, "There's an Argentine aircraft carrier in the bay, there are Argentine troops all over town, the governor and the Marines have been taken prisoner. The broadcast station's talking in Spanish, and basically it's all over. We've been invaded by the Argentinians." I then went on Radio 4 on the PM programme. There was no continuous news in those days with this story. Was then rung shortly afterwards by somebody I thought was from the Foreign Office, but I think may have been from an intelligence officer, to ask what I knew. And I told him what I knew, that it was all over. And about 50 minutes later, Lord Carrington stood up as Foreign Secretary in the House of Lords and announced that the invasion had happened. Now, what has really amazed me about these papers, which have come out today, is how crucial that information I gave them was. First of all, to be honest, I'd forgotten how much detail there was there. Thank heavens it was right. And it really was the basis for pretty much everything they knew in those first hours. It was the only intelligence, it was the only hard information. The chap I was speaking to, Bob McLeod, was not in Port Stanley. He was 50 miles away, but they had a very good VHF link up around the islands, and his information was good. As it turned out, it was spot on. And that is how the day developed.
Moving on, well, there were lots of seals. I haven't got many pictures of them. Just let me check that you can hear about shag rocks. Is that all right? Can you hear, David? Can you hear? Good. Okay. Right. This was a big surprise on the trip. The actual shag rocks, they're 240 kilometers before you get to South Georgia. So after we actually sailed from South Georgia, we actually had to, we passed these on the way to South Georgia, but some way. I was not aware that they existed. They're not very big. You can see the stats up there, and you can see a picture here, and whoopsie-dee. And here we have, in fact, you can actually see the shags on top of the rock. That's a picture of the middle section taken with quite a telephoto lens. And anyway, those were very interesting in themselves. If you look very carefully, there's a little bit of foam here. Now, I think that was from a whale surfacing, because when we were there, and here's the next picture, there were over 200, the biggest recorded pod of humpback whales, which has ever been recorded. And it went on for nearly an hour. They were all around there, and the ship, the MS Fram, actually was hove to, or heave to, or whatever it is. And I was taking photographs actually from inside, not up on deck, from inside. And here are the kind of whales. You can see just how close they are to the ship, and see the humpback of the whales. I would have put more pictures in, but I didn't have time. So that was really quite something. It's the biggest recorded number of whales. And that is actually very optimistic, because it means the whaling, which has been going on in the Antarctic, has actually reasonably stopped, not entirely, but in fact, some of the whale populations are growing back again. Now, one of the big explorers, and when we actually landed on South Georgia, was at Grytviken. This was the Ernest Henry Shackleton explorer, and he was a great guy. And one of the things was that he had this fantastic journey where his ship got stuck in the ice and never did cross Antarctica. Then he actually, after a year, and then the ship got destroyed, and then he actually took his crew up to Elephant Island, and then across with a smaller boat to South Georgia, and then had to hike across South Georgia with no map, and eventually get a relief ship. And on that expedition, although his ship was completely destroyed, then he did not lose one single man. It was really quite the last of the heroic trips. Here we are in Grytviken with a ship which is actually a little bit rusty. And behind us, we have got a whaling station. And unfortunately, I hadn't got enough time to put in a picture of the whaling station. Right. And but then you can see where, again, although there was a jetty, we couldn't land on the jetty, so we came in the boats, and that was a picture that we had. Now, also in there was a museum and lots of stuff, but I thought I'd show this, some of the technology of the Antarctic, some of the early whaling communications equipment, and that was some of the early communications. There were radars as well, but I haven't managed to put a picture in on that. We also, in South Georgia, at a different place, not there, we saw the king penguins, and also actually some in before, but it was really particularly nice to see the king penguins, another variety of penguins, and it's amazing the way they all cluster together in that way. I'm going to skip past that. I'm going to talk about the old MS Fram, because it relates to what I was saying about the Ernest Shackleton in the Endurance. This was the MS Fram, which was the precursor of the ship which we originally had, and of which we were on, and it was built by Colin Archer, and he was from Larvik, Norway, but he was half British, and hence his name. His father was British, Swedish, and Norwegian mother, and it was really a most remarkable ship. And the stats about the guy is shown on the right, Colin Archer, but the really key thing about it was it had a flat bottom. It also had a rudder and an engine. Well, the original one was a steam engine, but the screw could be lifted up. So whereas the Endurance, which was Shackleton's boat, broke up under the ice, this one never did. It was on the ice for months at a time, but it simply, with its flat bottom, floated up on the top, and you know, just waited. And the chaps camped in there, and then they sort of got back quite successfully. The other interesting piece of technology, I think it was one of the first combined steam and sailing ships, but it then, for its later journeys, actually took out the steam engine and they put in a diesel engine, which is again an interesting piece of technology. That's a picture again of from the National Geographic of the albatross and an albatross colony, just to fill in there. Now we move on. This particular journey is from Ushuaia. We went to Fort, then we went to South Georgia, and then we moved to various places, very successful on the mainland of Antarctica. Sorry, the peninsula, some of which was a mainland, connected. That means connected down through this bit here. And also a particular place which was to great interest to me, which was called Port Lockroy. And Port Lockroy is tucked away in a really sort of quite sheltered cove and had a microclimate of its own. It was a very interesting research station. Well, when you get to Port Lockroy, and I'm sorry I haven't had a picture to put it outside, you find that inside it there is a piece of equipment shown here on the right, which is called an ionosonde. Now that was a particular interest to me, this piece of technology, because when I left the university, one of the things I considered doing was actually going to Antarctica. In fact, I put it off, but then I thought about doing it again in 1965, 1966. And I would have certainly have gone to have been working this particular equipment, perhaps not at Port Lockroy, but elsewhere. What it does is to measure the ionosphere and how shortwave radio works. And this is of particular interest in the technology, which was very ancient. It had an aerial, the great power was a kilowatt operating thing, and it had an antenna up on the roof, various aerials, transmit aerial and a receive aerial, and they were actually separate. but it tracked over frequency. You'll see the kind of thing it does on the next slide. But the way it tracked was by a motor driving tuning capacitors, one for the transmitter. Well, it was a super het receiver, and it was arranged so it would transmit and receive in suitable way. And the technology was really old and high powered, and it had valves in it, and it was really interesting, particularly interesting to me. Now, what it does, it was a Union Radio Mark II ionosonde, and there's some history about it. There's another one shown on the right with a guy with an avometer trying to mend. Actually, it looks like the capacitor, motor-driven capacitor part, or check it out in some way. This was not at Port Lockroy. It was down at Winter Island, which is some way south of that region. But going up here, this is what it used to measure. It used to sweep a frequency across, and it used to measure the height of the ionospheric layers. And it represent them, if there were multiple reflections, you would see quite strong signals going up. The interesting thing was that down here, they got multiple reflections from ice. In other words, it reflected going downwards as well as upwards. The radar or radio signal reflected. And that gave a very good clue that if you wanted to measure the ground through ice, that you actually had to use a low frequency down in this region of low frequency, sort of 1 or 2 megahertz, and you had to measure down in this region. It was much more sensitive to penetrating the ice, and so that was one of the discoveries they actually made back in the early days, about up to the 1982. Well, that was 1975, this particular one, but that was precursors for the radar technology, which was later. Here is actually a picture of it's now called Wordie House. It's base F. It's in the Argentine Islands, which are not owned by Argentina, and there's some history which is on that. Now, I have gone rather quick through things so far, so I will now start to sum up, and I've also skipped over some of the things. It's now back to Antarctica and climate change. The 90% of the world's ice and more than 70% of our planet's fresh water are held in Antarctica. Now, if all of that, all of that plus, well, after all, it's 90%, but the other plus the other 10% of ice, then the sea would rise 70 meters, 230 feet. Now, that is quite a lot, and it would change geography forever. Now, the 1% rise in sea temperature, it gives a 2.3 meter rise in sea level, but it actually will take 2,000 years to do that. So there's an apparent contradiction there. Although there's an awful lot of ice there, it is melting very, very slowly. And okay, for example, it's still quite slow, but it is accelerating from 1900 to 2016, 16 to 21 centimeters. The history doesn't tell exactly what it was per that period, which is just a little over a century, but is now accelerating to 30 centimeters per century. So the rise of sea level is accelerating. Now, some facts and figures from the international conference, sorry, I haven't given the climate change conference, IPCC. The radiative portion, now this is telling how much the sun is guilty or not? Well, the actual amount of a clear day, the sun warms the land and sea by 1 kilowatt per square meter. So that's on a clear day. Now, you can, other effects, which are called radiative forcing, it modifies this. Aerosols, they are getting better, as I've already mentioned, zero Cs, and it's still quite small. The amount it contributes will be actually negative. It's going down 2 watts per square meter. So it's a very small percentage of the amount that is in fact contributed by that the aerosols. But actually the worst effect of the aerosols is to dissolve the ozone load, so people fry by ultraviolet. If you're in Australia, or actually in South America, it's worse. But when you look at CO2, there's no doubt the worst culprit is actually CO2, and it is positive, and it is going from, it has an effect of still quite small, but 2.2 to 7.6 watts per meters, and all the the projections range quite widely. Now, some other facts and figures. If the East Antarctic ice sheet melted, that's only part of what you'll see on a map in a minute. It's divided into 2. The sea would only rise 53.3, but if West Antarctic actually dissolved, then it would rise much less than that, 3.3 meters. Now, the other rather interesting thing is that the level of snow, and this is not much taken into account, the level of snow falls in flat parts of the America, the snowfall, it rises by about up to 1 meter per year. And in fact, one of the ion sondes, which actually was transferred to the Halley base, after 18 months, it had descended down to a level that it had to be jacked up, or it had to be put on a jack to be able to jack it up, and all the masts actually were collapsed by ice. So now that is actually a very important thing. We'll actually find in a moment, well, I'll say it now, that in fact it compensates, well, it's down here, it compensates for the ice shelf lost above by estimates of up to 80%. So in fact, Antarctica in the central part is actually getting considerably high. It's already up to about 3,000 meters, but it's still getting higher. Now, looking at whether Antarctica is guilty or not for the warming, this is figures between 1993 and 2018, and this is the various effects. The thermal expansion, that's the rise in temperature of the water of the sea, contributed 42%. The temperate glaciers, that means in the temperate zones on the hills and, you know, not in either of the polar regions, 21%. In the Arctic region, the Greenland glaciers melting was 15%. And Antarctica, it was only 8%. So actually the Antarctic was not to be blamed under those circumstances. Now, so what's going to go on? What's going to be what was the history and the future of the Antarctic ice? Well, you can see in millions of years ago, and you can actually see that there isn't full agreement at 2 different sources for the guesstimates, the blue and the red. But whatever you say, it was considerably higher level than it was now by, well, 200 or 300 meters, much higher, millions of years ago, and you can see the various periods there. Now, if we actually just look right at the right-hand side, after the last, so in thousands of years, we can see down at the bottom, we can see the last glacial maximum and the meltwater that we, there was a pulse of meltwater here. This was with the glaciers sort of melting fast, but there's been a steady rise, well, glaciers melting, but it took quite a long time, took several thousand years, you know, for it to really melt out. But now it's flattened off, and we can see the curve on the top right. We can see how it's flattened off, the curves from 1870 to 2010. So there's no question at all. The sea temperature is rising and causing a level rise. And notice the scale over here is in millimeters, not in meters as it was. So it's really fairly small. But going back to what if all the ice melted, actually this was in slightly excessive. It was what the map would look like if everything melted. Now, there's actually a much better indication of that in the National Geographic maps, but they're copyright and I couldn't use them according to their copyright rules. But nonetheless, this is a Pinterest map which is available on the web. So you can see, looking over London, it just isn't there. So you can see what the difference could be in the future. So where is Antarctica losing eye? Here's the West Antarctica. Well, we've seen all that at the moment, and East Antarctica is over here. It's much bigger than the West Antarctica. You can see that actually it's in quite small areas that the ice is being lost. It really is in quite small areas. Right, that is giving you a really brief overview of some of the science and technology of Antarctica and its impact on climate change. So really, in conclusion, Antarctica is an out of this world, fantastically beautiful, but most challenging continent. Its challenges have and will no doubt continue to advance technology, and Antarctica, this is the most important point, it actually slows climate change down, but it's also a marker for it. Remember that it took 2,000 years for a 1 degree change to actually affect the ice, the sea level change. So a 1 degree change took 2,000 years to melt the ice on there. Right, that's finishing. I'm going to end my screen sharing and see if I can hear the questions from you, David, if there are any questions that you would like to relay to me. But I have still got sound problems with you, so I may have to jiggle things about to see, or we may have to resort to using the mobile phone again to answer the question. So let's give a trial. David, could you shout?
Yes, can you hear me, Mike? Obviously not.
I'm not hearing you. I'm going to change things round. Could you try again?
Can you hear me now, Mike? I'll telephone you then.
I really, you'll have to phone me up. Okay. Hello?
Hello, Mike.
Yes, the first question.
Well, we had a number of questions about the availability of recording, which we've answered just via text. There was an interesting comment from Ronald Murray, who was actually working in the Falklands between 2002 and 2005, and has given his, what I assume is a radio ham's handle, and he said, "Love your lecture." So that's some good feedback.
Kind of him.
Thank you, Ronald. We have a question here from Alan, who says, has work been done on the magnetic field changing, strength, heating from solar and cosmic particles, and maybe north-south differences in positron direction? Was it? I think that may say.
Yeah, okay.
This may be why many more marine animals are stranding. Their navigation is being affected.
Yes, work has certainly been done. In fact, the early work back in the early explorers were in fact, I'm just going to have to take the phone away from my ear because I'm getting feedback. But the earlier work was actually done. Well, some of the early scientific expeditions, Scott and Amundsen and so on, a lot of, well, Scott's expedition actually wanted to get to the magnetic pole, and the magnetic pole is a long way away from the geographic pole. It is, but it's also drifting about quite considerably. At one stage, in the historical stage, it was not on the Antarctic ice cap or Antarctic area at all. It was out in the southern sea, and it's still drifting about. Now, what the recent work has been done on that, I am less sure. I think it is still going on, but I haven't seen it being reported in the main sources. So yes, there are certainly interesting effects, but at the moment there doesn't seem to be a particular, what I'm aware about on the magnetic. So the answer is mainly, I only know a little bit about the past, and I don't know much about the present, and certainly not yet the future. It's one of the things I'll have to look up.
Okay, thank you, Mike. Roy Stone, thank you very much for an interesting presentation. Thank you, Roy. Steve D, if the sea level is currently rising, yet the time constants are so large, 2,000 years, does this not imply that the temperature changes responsible for the present rise actually happened some centuries ago?
Interesting point. Up to some extent, that it might be considered to be true, but I think the temperature rises are more. The temperature rises are in fact more directly related to it. It is an interesting factor. I think the time constant is very slow in Antarctica and much faster elsewhere in the sea. So there will actually be a delayed effect. If it's ice melting, it is very slow, 2,000 years. But if it's just warming the sea, that happens very much faster, certainly within years or tens of years or year by year, certainly. So the warming effects are certainly much more immediate. But in fact, the global warming of Antarctica is so much slower. It really is a beneficial drag on the sea warming, the Antarctica. What it also means that it is not too late for us to do something about it. So it is. We've had a great success on the aerosols, the CFCs, reducing the ionosphere. If only we could do the same on carbon, we would be in a much, much better state. So, in fact, it is a real argument, the ecological argument for carbon, getting carbon down is really true. And that it really is very fast. But it means that if we can reduce the carbon, then the sea temperature will actually reduce or stop rising, at least, quite rapidly. So it really is urgent to get the carbon capture thing sorted out. That's the best I can say at the moment.
Okay, This is from Alex, who says, how do the sea level rise numbers add up? 53.3 meters if West Antarctica melts, 3.3 meters for East Antarctica, but Antarctica has 90% of all the world's ice, and the rise would be 70 meters if it all melts. 53.3 plus 3.3 is much less than 90% of 70 meters.
Very good question. It is flaky. The numbers are definitely flaky. I took them from two different sources, and the 70 meters is, oh, well, first of all, the numbers are a bit flaky. So if you add them all together, plus the Antarctic ice, plus the ice elsewhere, then I think you will get a roughly correct answer. And I have a nasty suspicion that that 3.3 figure, it was certainly quoted, but I didn't have time to check it. The 3.3 for West Antarctica is very much of an underestimate. But there's no doubt that the overall effect of the Antarctica cooling is very, very slow. So it is flaky. And also the Pinterest map is far greater. It's 100 meters, I think it's saying. So that is real doomsday stuff. It is 100 meters, which is well above the 70 meters. So that is certainly a doomsday situation.
Okay, we have a question from David. What are the priority research topics for the UK stations on Antarctica?
Good question. Again, I think a lot of it is to do with taking ice cores at the moment. That seems to be the current thing, which I didn't have time to talk about. But it actually digging through holes in ice and taking, well, it's a long way down through, 3 kilometers of ice and further on down. But that seems to be the one of the current important things at the moment. Anything to do with global warming, trying to get the history out. The other thing is exploration by various means of the lakes of which are under the ice. The important piece of research on that is when they drag the cores up, is they have got organic matter in the cores, which actually is giving a history of Antarctica back for, well, millions of years. And hopefully it will be able to also go back into the fossil times and actually find out some of the history of Antarctica. But that is actually, I think, the most active thing that I am aware of.
Now I have a question from Martin. Does movement in the South Magnetic Pole mirror changes in the North Pole?
The answer is I don't really know. I think it only does so rather roughly. One interesting fact which I do know is that when the magnetic reverses every several thousand years or 10,000 years, or no, it's 100,000 years, whatever it is, it goes through a period where the magnetic field is very weak, about 5% of what it is at the moment. And also there are lots of little north and south poles scattered all over the surface of the Earth while it is moving. So it's not homogeneous, it's not easy, and it's not easy to understand. But back to the original question, then I think the answer is it may be reasonably in synchronization, but not exact at the moment. But when the thing is collapsing during the next cycle, then it certainly will not be. It will be all over the place.
Okay, we have a question from Bob Hammond, thanking you for a very interesting talk and for preserving with the technology at the beginning. He says he was particularly interested in the BBC reporter who first heard the news from Bob McLeod about the Argentine invasion. Will this report be included on the recording with good quality sound? I perhaps should point out that the sound quality wasn't very good for that. I did answer someone else to say there is a link on the slide. So if they look at the recording, they could make a note of the link and find the original. But we may be able to post up that link somewhere so that they can read the or listen to the original recording.
Yes, I think did I put a link on the slide? I thought I had. I intended to.
Yes, the link is on the slide. So
now, let me explain that link. That link is indeed to the recording of Laurie Margolis, but it's what I actually tried to do was, well, successfully did, was to extract the recording from all the advertisements and so on, which that link goes to. But I cannot publish the link which I used to do the extraction. That is not possible. So the link will be available on the published slides, but the question of getting it into the recording is going to be difficult. But if you want to hear it, then do operate the link which you will see on the slides, which are on the recording. And David, you and I will have to discuss and see what we can and cannot do on the recording. Maybe it might be possible to do an additional, I'm thinking aloud here, to do an additional recording of just that bit, which we could load up on the website as a separate issue and do it that way.
But of course, there will be a PDF of your slides posted on our website, and that will have the link on it.
Yes, indeed.
Okay. We have a couple of thanks from Steve and Bob. And then we have a question from Alex. Can you elaborate on the biosecure procedure you mentioned? You had to step into a boot cleaner, but you still had to clean them yourselves as well.
Yes, indeed. It was quite a procedure. It really was taken very, very seriously indeed. The thing is that things can lodge in the treads of the boots. But what I didn't have time to say, although if we took a backpack, we had to have that clearly inspected. Also, I didn't have time to say, and it's all related, that on the South Georgia, they are now free from rats. They've had a rat eradication program for several years, which has only just recently come into fruition, 2015-ish, of getting rid of rats. So they're quite rightly paranoid about the possibility of rats. So when we, this is biosecurity, when we were about to land on South Georgia, we were inspected by the local authorities. There's only a population of about 15 on the island normally, but we were inspected by them, one of them with a dog. And the dog actually sniffed around the ship to see if there were any rats on the ship which might have gone aboard by.
Then Harold asked, is it possible that the higher sea rise figure includes the accompanying thermal sea expansion? So is it possible that the higher sea rise figure includes the accompanying thermal sea expansion?
David, Mike's dropped out of the webinar, so we'll no one will be able to hear his responses.
Yeah, hold on a moment. Yes, I was just going to relay the answer to that question. So yes, it does include the sea expansion. Everything's included within that. Yes, Mike has, he froze and lost everything, so he's just rebooting, and I'll relay the answer to the questions whilst he's doing that. So another question, Mike, or a comment that they really enjoyed the talk, and thank you. And was very interested in the map showing the currents around Antarctica. And the question is, do they vary significantly between summer and winter? Right, Mike says, yes, there is a slight variation, but it's not actually that much. So no matter what time of year you go, the circulating currents are much the same. And the Drake Passage was pretty bad, apparently. Okay, Alex says, you mentioned the ice radar measurements use SAR, including the old data. Does this mean they can reformat the old data to make it SAR-like? Okay, I'll try and relay that. And so, yes, they can change it, but they're using computer tomography, and SAR isn't that, but it can be converted and adapted so as to combine the information. All right, and Mike adds that the gaps in the data are filled in by glaciologists so that they can sort of show the complete history. Okay, fine. Oh, there's two more. One more question, really. I mean, there's several people, including Paul, thanking you very much for that. Oh, and Cliff is also saying thanks for a very interesting talk and memories from visits to the Falklands and Antarctica. So that's the end of the questions, Mike. Right. So I'll close out. So I'll just say, Mike, thanks for your perseverance and thank you for the questions. And his apologies that his internet link has frozen. I mean, on behalf of the Sussex network of the IET, I would certainly like to pass on our thanks to Mike, A, for persevering initially and getting the technology up and running, but also for having told us a fascinating story of his visit and the related technology and lots of information about the Antarctic. As we've said, we will be posting the video recording, and there will be a PDF version of the slides available, and we'll let you know when they're up on the IET Sussex Network website. So thank you all for joining and for persevering with us. So good night and keep safe. Bye-bye.